Hello. Good morning, good afternoon, good evening to everyone in the audience from around the world. My name is Stu Pringle, and I am your host for today's session. Welcome to Transition Pieces by Apollo. This is the third episode in a series of live expert panel discussions that we've been running in recent months, with the overall season strapline of putting a spotlight on the energy innovation. Um, each of these three sessions has looked at a different topic, and today's title is hydrogen the silver bullet for the energy transition? This is number three of three. So if you've missed the previous two, where have you been? But in all seriousness, thank you for coming along. We will forgive you, and welcome to today's session. I'm sure you agree it's a big topic, and no doubt there's going to be a lot of debate. And you know what? I've said to the panel, they cannot say that the answer is just yes or no. Today, my friends, you're going to have to explain your working during the discussion. Okay, so what's the plan for today? We are going to do a total running time of around about 45 minutes. We're going to split it into three parts. We're going to have and some initial thoughts from Phil Westmorland. We're then going to open it up to our panel debate. And then at the end, we're going to take some questions from you lovely people in the audience. If you would like to ask a question, the way that you do it is by putting it straight in the comments below the video on LinkedIn, and that will come into the feed here. And when we get to the comments section, we can start adding them in to the right-hand side of the screen. So we'll be able to see your questions and we can pick them up there. So if you're watching this via LinkedIn right now, please say hello and the panel will see the comments. And if you'd like to ask the panel a question, we will do that towards the end. So let me introduce today's panel. Today I am joined by Phil Westmorland, who is a process engineer. Phil is a fellow of IChemE and has 20 years experience in energy. He's spent his early career in mathematical modeling of process plant, and he later moved into plant optimization and currently heads up Apollo's decarbonisation business unit. Along with Phil, I'm joined by Don Harrold. Don is Statera Energy's Hydrogen Projects Director, and he's responsible for the delivery and development of their portfolio of hydrogen projects. Don has extensive professional experience working in a variety of senior roles with top-tier EPC contractors in the oil and gas and petrochemical sectors. His most recent experience involves leading the gigascale green hydrogen projects, including Statera's landmark 3 gigawatt project at Kintore. Don, thank you very much for coming along. I've also joined today by John MacLaren, who is Director for Waste and Generation at Stantec and has worked in energy and utilities industry for over 20 years. He's been heavily involved in decarbonisation projects, from the UK's first industrial scale biomass boiler to multiple advanced thermal conversion technologies. Most recently, he's worked on projects involving blue, green and turquoise hydrogen and is looking to support these through the next phases of design and delivery. He's worked in both design and operations and now leads the generation team and is heading up a wide range of decarbonisation projects. Thank you, John. And last but by no means least, joining us, actually, who only joined about 10 seconds before we went live, which was good for my nerves. And we're joined by Henry James, who is Wales and West's Utilities Net Zero Portfolio Manager for Industrial Clusters. Henry is a chartered engineer and responsible for delivering the company's contribution to industrial cluster initiatives such as the South Wales Industrial Cluster, including the development of infrastructure projects such as Highline Cymru. Okay, there we go. We have a serious heavyweight panel with us today. So, a little bit of housekeeping. I mentioned the chat post. Please, if you're in the audience, because we've got a big audience today, say hello, don't be shy, and do throw in some questions as the chat develops today. And then towards the end, we'll give you contact details of the team at Apollo after we kind of bring our questions and answers to a close. There you go. There is more than enough introduction from me. I think it's time to let some others speak. So without further ado, I'd like to pass over to Phil for some initial thoughts on today's topic. And remember, Phil, it's not allowed to be a yes/no answer. You've got to show you're working. So, is it the silver bullet?
Okay, I'll just start really briefly in the area of business that I'm involved with in Apollo. So we are commissioned by our clients to sort of focus on decarbonisation solutions, so emissions reduction, energy efficiency, on alternative fuels, biofuels, biogases, hydrogen production facilities, e-fuel facilities, heat networks, energy storage, carbon capture, all that really good stuff. And we provide it from advisory through to engineering. So based on sort of all of these commissions, my own research, history of energy use in the UK, my answer is hydrogen, the silver bullet is a no, whether that's fortunate or unfortunate. The reason why it's a no from me is that the answer is going to be all forms of energy technology will needed to support the energy transition. But most importantly, we need to be reducing our energy use and being much more efficient. Together with looking at, is the centralized approach to energy correct? Is some of our traditional thinking correct? And it's a challenge that the government and industry face, but maybe more broadly society face as well in our habits and what we're willing to accept. Do we want the same way of living to be unaffected by net zero, or prepared to change our habits to support net zero? And I'm always drawn to a lecture that I attended at Bristol University around net zero, and a student in the audience asked the lecturer, based on this complex task of net zero, what can I do now to support? And the simple answer was almost like a drop the mic moment, was, really consider if you need to buy avocados from Peru. And it was quite a profound statement from the lecture, but it has loads of connotations in, how does that avocado get from Peru to us? The carbon footprint of that, what's fueling that, what's the energy source and that. So what I'm trying to say is, so when we think of a silver bullet or an alternative, we do need to think about the bigger picture. It's very hard for any silver bullet or alternative to just drop in and replace something without different, further impacts. And their impacts can be cost, their impacts can be security supply, resilience, and risk. And all of these need to be managed. So in my opinion, there's no real silver bullet to net zero. There's lots of good options when applied appropriately. So that's my set the scene, as it were, from myself.
Thank you, Phil. Thank you very much for that thought-provoking opener. I think we are now fully up and running. Let's open this up to debate. So the first question that I would like to ask today's panel, and Phil, I might just bounce this straight back to you, is
Yep.
where do you think hydrogen is going to have the greatest impact?
So I think when we talk about hydrogen as a silver bullet or as has the biggest impact, we always need to be talking about hydrogen created from low carbon sources, or having a low carbon footprint. We don't just talk about hydrogen in all forms. So firstly, we really need to displace the chemical use of hydrogen. So when I say chemical use, there's lots of industries such as steel making, production of methanol, fertilizer production. All of these currently use sort of what we deem grey and black hydrogens, hydrogen with a large emissions or a large footprint. So we need to be replacing those low carbon hydrogen in the first place. And if we then consider hydrogen as an energy carrier, then secondly, we need to again revisit the social use of energy. Number one, reduce that energy use and improving efficiency, and try and avoid any of that rebound effect that we're currently experiencing probably at the moment, where historically energy costs have been low. We might not feel that at the moment with the energy bills, but oil and gas is a little bit of a golden egg in terms of cost per unit of energy and how diverse it can be. And we've historically continued to use more of it in different ways. So when it becomes cheaper, we ended up just using it more of it. We turn up our heating in our house because it's a bit cheaper. So all of the alternatives to fossil-based fuels, are challenging. So, and what I'm saying is that we need to look and explore those alternatives like hydrogen. It can be more costly, but we also need to look at the whole ecosystem, the amount we need, how we're going to store it, what's that security supply, and how does that resilience come in? and it doesn't always automatically translate to an individual's pocket. So the example of this would be if we're going to electrify buses or use hydrogen for buses within city centres. That improves air quality. It has a net positive impact on the NHS. It would then reduces lung-related diseases. So it's sort of like indirect benefits that are sometimes harder to quantify when you're just looking at energy bills or energy use directly.
Okay.
So back to the question, probably. So once we've displaced chemical use for low carbon hydrogen, I think the biggest impact as an energy carrier will be long-term energy storage vector. So where we can use it as like a dispatchable energy to support balancing the grid, support high heat industries. On from that would be hard to abate areas, such as options for heavy transport. Or someone talk about heavy transport, so heavy haulage and shipping, and the aviation sector. But this might not be in its pure form. It might well be as a feedstock that goes into the production of a SAF, sustainable aviation fuel, or as an ammonia, or as a methanol. And remembering in these scenarios that you have sort of carbon neutral fuels and net zero fuels. And then on from that would be supporting industry for heat and power. So that would be my take on, like the greatest impacts of hydrogen. But that's not like across the board within each of those areas. I think it's part of the mix where it makes sense, where it's appropriate, where the economics stack up, and where the safety case can be demonstrated.
Thank you, Phil. I think it's about time we let someone else in. Come on, who'd like to pick up the baton on this one? Any views on top of what Phil's already discussed?
I think I agree with a lot of what Phil said. So heavy industry is notoriously going to be difficult to decarbonise or electrify, as is probably the preferred way to decarbonise the UK's infrastructure. It's going to, if we did try to electrify a lot of these industries, the capital costs would be phenomenal, and that will drive business away from the UK. So we need to have something that's responsible and quite cheap or easier to install. And hydrogen does fill that gap. So in some ways, it could be a silver bullet in some industries. The big problem, as we said, is it's not cheap. It's not going to be too cheap to produce, especially green at present, given the power price and the inefficiencies in electrolyzers, etc., which drives the price up to around about 3-4 times the price of natural gas. On the flip side of that, we are in the UK in particular looking at installing a lot of wind and a lot of extra solar. Now, even at present on a windy day, we do have a lot of events where we actually have to curtail or turn off a lot of wind turbines. Now, if we install more, i.e. 2 to 3 times the amount we have now, then we're going to have even more curtailment events where we're going to have to turn off more turbines more often, even on a reasonably breezy day. In that scenario, hydrogen or that electricity, which would be turned off, could effectively be used and given to free to produce green hydrogen. And provided the storage solutions are there and in place, and storage is possible with hydrogen, depleted oil wells, salt caverns, those sorts of things, it could play a very important part in helping into decarbonisation and also in energy storage, so hydrogen to power. And I think Hydrogen UK have just released their report on hydrogen to power, which is a really good read. If anybody out there, I would advise downloading a copy and having a look through it. It does offer a lot of advantages and brings us a lot further towards decarbonisation. In terms of, is it the silver bullet? Probably not, but it's one of the silver bullets. There's going to be several, I think, and they all have to join up together in order to work.
Thank you very much. Any other thoughts before I move on to next question? Don, Henry, happy for us to keep going?
No, I think
Go
it's
on, Henry.
I agree with many of the points being made. I think the only thing I'd add to that is that there is an increasing role to play for hydrogen in transport and road vehicle transport, something which I know Phil mentioned in maritime applications, but actually as well, from a gas network perspective, if we completely ignore our gas network, we also have a fleet of whatever 1,000 vehicles on the road to maintain that network, and traditionally quite heavy vehicles, and a lot of utilities companies and other sectors use heavy vehicles in that respect, particularly if you're looking at the typical kind of white van or transit van. Now, there's no current kind of other available option for those vehicles to meet net zero other than hydrogen. So having hydrogen play a role in commercial transport also makes a lot of sense in some cases. Clearly, lighter vehicles, electrification might be the option, but for heavier ones, hydrogen looks to be part of the answer, at least for some uses.
Okay, brilliant. Thank you, Henry. I think we should go to our next question. And Don, I'm going to put this one straight to you, if that's all right. So our next question is, can hydrogen match solar's cost reduction curve? Why or why not? Don, over to you on this one.
Okay, afternoon, everybody. I mean, solar costs have fallen dramatically, and even in the last 10 years, it's really pretty impressive levels of reduction. And I think for any industry to match that is always going to be really a challenge, I think, and probably hydrogen included. However, I do think there is significant opportunity to reduce costs. The core technology, electrolyzers, will fall in price. There's certainly significant potential for technological innovation. I think as plants scale in size, then we'll obviously get benefits of economy of scale, and all of that will drive down hydrogen prices significantly. I think we're pretty confident in that, in the work that we're doing. So I do think there's a significant opportunity to reduce costs and pull down hydrogen costs with it. Would it match solar? I think that's going to be probably a tall order in truth, but there's a significant journey to go on, and really we're at the start of that right now.
Thank you, Don. Anyone like to chip in on this one?
I'd say there's two elements to that cost reduction, isn't there? There's how we drive economies of scale and how we drive technology costs down. But the other thing you need for hydrogen, if you're looking at the green hydrogen, is power costs. So they need to come down. So there's they're not mutually exclusive of each other. So in both cases, we can try and drive down capex, which can be a smaller proportion of the levelized cost once you have the UK's high power costs at the moment. So yeah, we can drive down power costs. Will then again help us try and get that cost reduction curve a little bit steeper. That would be my 2-penny worth.
Yeah, I think
very good.
Electricity prices are high. Private wire connections are obviously going to offer quite a reduction in that, because around about 50% of the electricity bill you pay per megawatt is add-on charges for grid use, DNO connections, those sorts of balancing charges, etc. So private wire will offer a way, but solar is obviously used as free power. The sun is free energy. You will have some, and a lot of efficiencies. I agree with Don in terms of capex reduction. A lot of electrolyzer manufacturers are looking at using less costly materials in the electrodes, so not platinum group metals, etc. And that's going to improve. That's going to drive costs down. Recycling of them at the end of the life will hopefully also drive costs down. And then when we move into operation, I think we just do need to take a long look at how we pay for the power for these projects. If it's grid power, is it going to be expensive, or is it going to be some way subsidized, or what?
Thank you, John. Okay. Well, look, I think it's time we shift gears a bit. Let's move away from the question of technology type versus type and think more about the infrastructure side of things. We've already touched on grid connection, but what about some of the discussion around the ability to repurpose infrastructure or not? What do we think is the path that we should take, panel? And Henry, I might send this one in your direction first.
Thanks, Stu. Yeah, so in terms of repurposing gas infrastructure and specifically gas network infrastructure from our perspective, so there's been a lot of work undertaken in the past 5, even a longer amount of time into looking at how the existing gas networks can be repurposed to transport hydrogen. Clearly, a lot of that depends on what the gas network is connected to, what customers it serves, and what types of demand there are connected to the network. Now, the work so far has very much focused around domestic and how we support policy decision for hydrogen for heat. That work is by and large being completed as part of the village trials, which we know were abandoned a couple of years ago. That's now moved on. We're now looking at providing that evidence without doing the trials to government to support those decisions. But to do that and deliver that in a national perspective, we have to look at the near term as well, and what new build infrastructure would serve in advance of mass repurposing. Now that clearly, as we're seeing in the clusters now, as we're seeing through the number of applications to Ofgem last year, which have all been published for funding to progress these projects through feed studies, for example, and there were 12 in total. All those projects are focused around connecting industry with large blue and sometimes green hydrogen projects within the clusters. That we see it as being the pathway to mass repurposing. So some of the analysis work that we undertook, and I know this view is reflected amongst other networks and clusters as well, is that actually if you build a little bit of new infrastructure, you can unlock a lot of downstream network. So actually if you build a little, you can unlock a lot in terms of a future policy decision and repurposing that network. And that's really the path I think to take. So in terms of repurposing and building new, I think the answer is both. Clearly the value for the customer, the value for the consumer, and the impact of consumer bill, it needs to be minimised through repurposing as much as possible. And to do that, you need to build a little bit of new to do that. I mean, clearly there's a discussion around how we do that alongside the programme of electrification and heat pumps, which the government is supporting, and which should absolutely be supported for certain property types in the right cases, because it's the most efficient way of delivering heat to houses, providing heat pumps can be fitted. But where that can't happen and where you have to decarbonise heat through other means, then we need to look at that in a holistic sense, and the short-term investment required to get hydrogen to the area where you can repurpose.
Fabulous. Thank you, Henry, for that insight. Is there anyone else at the panel would like to pick up the ball there and talk about?
I think repurposing is pretty much essential if the UK is to meet its green hydrogen target. So if we're going to get anywhere close to 10 gigawatts, then by 2030, then repurposing it really must happen, I think.
Okay. There you go. Gauntlet laid down. John.
I just probably, it's more of a question for Henry. So obviously, if we are looking at repurposing, we obviously don't want to impact the existing users. So that's obviously going to make Henry's job quite a lot more complicated and challenging, shall we say. Obviously, you don't have dual gas pipes everywhere, but you do in some instances. So an understanding of that, the level of investment needed for the new bits and pieces is going to be challenging and not a simple solution, I don't think. But it is, I agree, to hit any of our targets, we will need to repurpose significant volumes of pipework.
Okay. Henry, would you like to respond to John's thoughts there?
Yeah, no, it's a really good point, and one of the key benefits which of having a gas network that the network has that the industry has benefited for a long time for is that resilience, is being able to be connected to the national system, large scale storage, and what a lot of people perceive to be an infinite tap of natural gas. Sorry, that is, and obviously it's not infinite, but that's how it fundamentally operates at the moment. It's very resilient, and to design a new network for hydrogen alongside that and look at a long-term transition is a huge strategic, needs to be approached in a huge strategic way, and to maximise repurposing whilst maintaining that level of resilience for existing natural gas customers, many of which will be hospitals, will be major manufacturing facilities, and will be domestic properties and clusters of domestic properties which won't be able to convert to electric in some cases. Being able to do that to make sure everyone transitions in a way which is beneficial and least cost, it is a huge challenge, and one that needs to be carefully considered, I think, as we move forward and the policy is written.
Sure. Thank you, Henry. Okay. Okay, team, we're reaching the halfway mark of today's session. So just a quick word to the audience. Remember, we're going to do some Q&As a little bit later on. So if you're on LinkedIn, you can see Jonathan's put a comment in at the start of the discussion. Please feel free to start adding in your questions, and we shall pick them up in a few minutes' time as we get later into today's debate. But for now, I'd like us to move on. I think we've had the eye of Sauron on Henry for long enough. Let's move on to another topic. Let's talk about some of the colours. So blue, green, or pink hydrogen. which production pathway should we prioritize? John, I feel this might be one that's good place for you to start on this one.
Okay. Yeah, I think, well, the short answer is all of them. I don't think there's going to be one we can prioritize over any other. I think obviously blue, which is hydrogen generated from methane with the CO2 captured and then sent offshore underground. That's going to be key, especially in some of the hubs and heartlands. So Teesside, the Northwest, Aberdeen, etc. That will form a base load of hydrogen that will be effectively available 24/7 when the wind's not blowing, the sun's not shining, to allow industry to have confidence in decarbonisation. And that's unless there is major storage infrastructure built. Green's obviously the one, and very similar to pink in that it's the one when people think about hydrogen, it's the one people think and it is the cleanest, and in a number of ways it is. But obviously that depends upon having access to sufficient power, sufficient water, and in some instances land and technology. And we know that this is going to be probably very large scale. It can be decentralized. It's a modular type systems, typically, sort of anything from 2 megawatt modules all the way up to 10, 20, or 17.5 in Siemens' case, megawatt systems. And that will be important moving forward. Pink's obviously very similar to green. It's just the source of electricity is quite different. But I also think turquoise hydrogen is going to have a role to play in the industry. Now, turquoise hydrogen is taking natural gas and pyrolyzing it, so either heating it up or thermally splitting it in some way. So you get a carbon solid black product, and you also get pure hydrogen. Now, that is potentially promising in probably some more niche markets, slightly more small scale. But as well as giving you hydrogen, it gives you a very pure carbon, which can be used in cement. It can be used in electronics industry. It can be used in manufacturing of tires. So that gives you an additional product, whilst also allowing you to capture the carbon where you're not near a carbon sink, such as the northwest, the northeast of England, where they can easily collect it and send offshore. So I think in a lot of instances that could play quite a big part in the industry. As I said, typically smaller scale, more decentralized, and that will compete with electrolysis. It will have less power input required, and it will have more less water requirements, and obviously less infrastructure needs. It will use the existing gas network. It won't need hydrogen, and it will be able to help decarbonize some industry.
John, thank you for such a well thought through answer. I'm glad you're here. I'm also glad you explained what turquoise was, because I was going to ask you, because I didn't know. So thank you. Who would like to pick up on that one?
Just a really little add-on. I guess for the turquoise one, if you use biogas or at that point as well, it becomes even more attractive as the generation of hydrogen, because you're not having to do the extraction. We're reusing something that we've generated at anaerobic digestion in the water industry, all of that type of good stuff. Yeah, and coupling that in obviously would make an improvement again, wouldn't it, on the potential for that application?
You'd have to, biogas is typically 60% C8 methane, 40% CO2. So you'd have to remove the CO2 first. Otherwise, you're going to split carbon and oxygen, and you don't want hydrogen and oxygen in the same pipe. So there would be a pre-step needed. But yeah, that's negative emissions effectively, which would be, again, it's one of the holy grails of decarbonisation. You don't want net zero, you want net negative if possible.
Very good. Anyone else like to come in on this one before we go to the next question? Anyone else got views on blue, green, pink, or other colors and pathways? So we've covered that one. Okay, let's move on. So next question to ask you. Let's talk about risk. What are the risks of investing in hydrogen infrastructure too early versus too late? And Henry, I'm going to come back to you on this one. I'd like to start with your views on this question, please. And good, we've got some questions coming in from the audience that we can grab in a few minutes' time as well. But Henry, for now, let's talk about risk. What's your thoughts, please?
So I think hydrogen is a new and emerging sector. I think in terms of risks of investing and in developing projects, fundamentally, we shouldn't look at hydrogen as something necessarily that's big and scary. It is being done in certain applications around the world already. There are hydrogen production facilities, connected to hydrogen networks, connected to end users, and it's working in practice. Clearly, some of the new technology you see coming through are more complex, actually higher costs, and there's potential obviously through that for projects which completely fail. Now, I think in terms of spreading the risk and sharing the risk amongst organisations, the government, as we know, are developing their business models at the moment, the hydrogen allocation rounds. They're also developing the hydrogen transport allocation rounds, or the hydrogen production, the hydrogen transport and storage business models, and the hydrogen to power business model as well, that we've had announced more recently. It's key from what we've observed that those need to be somehow linked together to enable clusters and groups of organisations to jointly invest in a larger project. So, for instance, to have a supported production site, a supported network, and a supported end user, for which there is less funding available, to enable these projects to go through. So actually, by designing the business models, and it's still very early days in the design of these business models, design them in such a way that they are complementary and can move at the same pace, and ultimately make a financial investment decision at the same time, you're ultimately sharing the risk and de-risking these projects. That's my take on it anyway. I don't know if the views of the rest of the...
Let's find out, Henry. Thank you for that. Panel, who would like to pick up on the risk question? And I'm particularly interested to know if too early or too late, what's the bigger Armageddon that faces us here?
I guess if you invest too early in infrastructure and there is a U-turn, or if there is a change in policy, what do you do at that point? You know, you see in the news with Trump has just suddenly cancelled all funding pretty much for green hydrogen, I think it was, or the billions, or paused it, should I say. You know, it's things like that I think would be one of the big risks, you know, because it does require a certain level of government support to get things moving.
It does, yeah. They're trying to create a market from scratch, which is never going to be easy. Investing early, you've got lots of risks, not just obviously U-turns on incentivization and government position, but you've got technology risks. We're trying something that's slightly new. It has been done before, but not at this sort of scale in a lot of instances. But at the same time, the incentives are likely to be better at the start than they will be in 4 or 5 years' time once the technology is more established. And the governments have got quite a good model in their hydrogen allocation round in terms of price incentivization, in terms of volume incentivization. And I think they will help to push the market. But what it really needs at this stage is people aren't going to invest until they have the guarantees from the government at this stage. And I think there's a lot of big projects. I'm thinking Don's probably got a few that are just waiting on just final confirmation of this from the UK government.
I guess there's a question from the panel. I think, well, the first one from Jonathan. If they each had one asked to the government to help move the energy transition forward, what would it be? I guess this is in the context of hydrogen, because hydrogen panel. But I guess that's the one that you're saying, Jonathan, is around certainty from the government for investment.
Yeah, the government wants certainty themselves, but I don't think they can get it, can they? At this stage, it's too early in the system, and I think a lot of the potential off-takers, they're going to have a lot of uncertainty in the capability and the guaranteed level of supply, at least in the early stages when there's 1 or 2 plants disconnected from a national transmission, national hydrogen network. That's going to be hard for companies that are used to a gas connection where it's there 99.9999% of the time, when the hydrogen might be available slightly less than that. So there will be concerns around security supply initially, at least initially. But as the market develops, those should be eased. But in terms of what we want, it's just clear policy, clear decision, and clear incentivization plans from the government, I think.
Thank you, John. Okay, let's keep going. I've got one more question to ask the panel, and then we will do a deeper dive on the audience questions. So sort of final moderator question is this. For grid scale storage, when does hydrogen beat batteries. Don, I'm going to bring you in first on this one, please.
Yeah, I mean, I don't really see them competing. If I'm honest, they do different things. So if you look at the different different technologies for storage, obviously batteries are principally pointed at intraday markets. Pump storage allows you to look at interday. But really, hydrogen sits alone as having the capability for seasonal storage and being able to take energy and store it in very large quantities and then use it at a later point, much later point. So I think really, hydrogen looks to me to be really the only technology there that can make that seasonal shift, and that's really where it has a strong competitor to well, there is no competition for that really at the moment.
Thank you, Don. That's really, really useful points. Anyone else like to jump in? John, I can see you nodding. You about
I
to
was
say a
just
few words on this
agreeing with
one?
Don. I think, batteries and hydro are good for seconds, minutes, hours, day or so at most. Hydrogen has potential for much longer storage, especially given in the UK, given our geology, especially offshore and probably the northeast with some of the salt caverns they have there and potential. So it's got. I don't think batteries will be able to compete, at least not in the short to medium term.
Understood. Thank you. Phil or Henry, any thoughts on the storage side of the conversation?
I guess it just reiterates that there's no one solution. We need all of it to some extent to support the transition to net zero. And the use of grid scale, that large scale storage, you can see the ability for hydrogen to do that, and you do need to disconnect slightly that the difference between the forms of energy. Electrical energy is definitely different to the hydrogen as an energy carrier. If you want to do work with it, you'd have to convert it into another form of energy, like electrical, but then you can use it for heat as well. So
it's not a simple answer, is it?
No, it's not a simple answer. It's what keeps us excited every day, though, Stu, I think.
Absolutely. Very good. Henry, you look like you maybe had some thoughts on this one, or are you happy?
Yeah, I agree largely with what the panel's saying. I guess it does entirely depend on the application. It depends on the medium of use at the end, and it depends on the repurposing as assets as well. Because clearly, if you can repurpose parts of the grid in certain areas, parts of the gas grid in certain areas, use line pack storage in the gas grid, or if you use new battery storage in electricity grid, then depending on the area and the makeup of the network, the age of the network and condition, then there are going to be different use cases and ultimately use cases for both levels of storage as well. So yeah, I'd very much say case by case basis and depending on end use.
Great, thank you. Okay, let's have a little look at what some of the audience have been saying. You're not too late, audience, to add your question in. We have some time now. So you can see we've had a few questions in. Phil, what have our audience been asking about? We've had something from Rachel, Phil, Bassie, Jonathan. Any of those that you'd like us to kind of pick up and kick around for a few minutes?
I think there's there's a good one probably for Henry, isn't there, on the repurposing, what the main challenges of pipeline repurposing and over what time frame can we make this happen. Very relevant, I know, to what some West utilities are doing.
Thanks. Yeah, sure. No, it's a great question. It's a great question. So we've already touched on some of the issues already, obviously maintaining resilience on the natural gas grid. So obviously to repurpose a pipeline, you're going to have to consider when you can take it out of service and when you can perhaps reconfigure the network if you have dual pipelines to serve existing customers. I guess once you've done that, you need to consider capacity of moving hydrogen through that pipeline, any new infrastructure you need to build to support that at either end, above ground installations and the like. From a purely line pipe perspective, you need to consider the condition of the pipeline. So some pipelines in the UK gas system will not be suitable for hydrogen repurposing, it's safe to say, because they're of an age where you'd have to lay a new pipeline to repurpose it, but a lot are. So a lot which are newer, a lot which are of a lower grade steel. So we're talking more around the X52 rather than the higher grades of steel, such as X80. You repurpose because they're less. Then you have to interventions you need to put in there to make sure that the pipeline has the integrity it needs.
Fab.
In terms of a time frame, purposing at the moment is LTS Futures, which is an SGN-led project, but collaborated on by all the gas networks, and that's looking at producing a blueprint for how we repurpose any LTS or local transmission system pipeline in the whole of the UK, based upon its age, its condition, its material, and ultimately providing a kind of a step-by-step, if you like, of how you would repurpose that pipeline if the need arose.
I guess it's also the risk profile along the pipeline, isn't it? And showing that the QRA stacks up along the pipeline with the new fluids that are being used, that whatever pressures they're being used at, type thing. Just thinking of, building proximity distances and things like that you're used to with natural gas might well change a little bit with hydrogen, depending on whether it's TD1 or TD3 code.
Yeah, absolutely. Yeah, and like you said, that's dependent on wall thickness, operating pressure, to some extent condition as well, and yeah, so that would have to go through that blueprint which is being developed at the moment to assess whether it's safe or not to repurpose in each circumstance, or whether you'd have to make extra investment to make it safe for hydrogen.
Okay, right. I think we've given that one a good go. Is there anything else, Phil, in the questions there that it's worth fishing out for the last few moments?
I don't know
today's session.
From yourself, Jonathan. Sorry, Jonathan's your official name, isn't John? The biomass electrolysis as becoming a viable source of green hydrogen. I guess with your background in biomass and waste.
Yes. So biogas electrolysis, it could become a viable solution. I know a lot of AD facilities already upgrade their biogas produced into effectively natural gas quality, so and inject that into the grid. So there is definitely opportunities for them to do that in some areas and some instances. One of the big concerns, obviously, is going to be cost for these things and a level of subsidy. So at present, they get a reasonable amount for injection into the grid. They would have to then upgrade that further, and it would have to be in the right area to allow them to either create hydrogen for a local industry and have that direct piped, or obviously repurposing of the grid when that comes along, then that would bring those opportunities there. If you're talking about biomass, then you can create hydrogen from biomass from gasification or pyrolysis of the actual solids to produce a syngas, and then you can clean that up and use pressure swing exhaustion or something to generate hydrogen. That is something that's probably is achievable, and I'm sure there'll be quite a few people out there who are trying to develop technologies and plants and projects to do that. It's not going to be easy. The UK's experience with gasification over the last 10 years hasn't been the best. There's a number of failed projects in just gasification to generate heat and steam. So doing that to syngas and having that successful and viable, it's not going to be easy, shall we say, and it would need somebody with some deep pockets to try and test and prove it on a commercial scale.
Very good, thank you. Don, you've been sitting listening to the chat for the last few minutes. Is there anything in this question or any of the others that's particularly caught your eye?
I guess technology improvements. I think there's a question from Rachel that says, where will it come from? And will it be driven by China? And this is specific, I guess, to electrolyzer technology. So I think there is obviously, when manufacturing moves east, costs fall. So that would be a case of taking existing technology and manufacturing more efficiently. I think also out there, though, there's a significant potential for improvement in technology, so that new technologies emerge that make a significant shift in energy efficiency, and that's always there's always potential for that out there, I think.
Excellent, thank you. Just watching the clock, we're getting towards wrap up and end of time. Does anyone in the panel have any sort of thoughts they've been desperate to say that perhaps we haven't had a chance to get to yet? This is your moment. We're going to open it up to any of you. Any kind of final thoughts on the tip of the tongue?
I'll jump in, but I think I've
Sure.
said it all before, though. But just from the discussions in this panel and other discussions that we have, like internally, and you have with your peers, it really is a challenge. Net zero and energy transition really is a challenge, and I think everything's got to sort of all hang together. Government, industry, society, technology improvements, they've all got a part to play to help us, with this shift. And, clean power by 2030, net zero 2050, there's lots of good targets. Seems like a long way away, but it's not. It's really not that far away. It's 20, for net zero to have, we've got a lot to do. So my thought is that, have we got too much to do in the short space of time that we've got? If we have, we need to just be getting going now. We need to be driving this forward. That's what I'd say.
Absolutely. Definitely agree. Okay, so I'm going to start to bring today's session to a close. We will be sharing this on demand on LinkedIn, as well as our previous transition pieces live casts. If you'd like to contact Team Apollo, you can either, I'm sure Phil doesn't mind a little DM over LinkedIn, but also you can see the contact email address there. So please do get in touch with Phil and the team. And that really leaves me to say thank you very much to all of our panelists today who have given up time in amongst their very busy schedules and their travel and their IT to make it onto this live cast today. So I do thank them, each of them, very sincerely. Thank you for coming along. And also thank you to the audience. If you've enjoyed this and would like to see more of these sorts of industry debates, please let your contacts in Apollo know. We'd like to do more of these and other content through the year. If you've got ideas for topics for discussion, send them in and we'll take that into account as well. But there we are. We are pretty much bang on time. So I think that leaves me to say thank you again to everyone in the panel. Thank you again to all of you in the audience and for coming along, and to everyone to have a great day. That brings today's session to a close. Thank you and goodbye.